All right, we have covered volume of cylinders and volume of cones, okay? The last is volume of spheres, which is a ball, a three-dimensional circle in a way. And this formula doesn't follow the same rules as the other two because there is no such thing as height when it comes to a sphere. There's not a height involved. So with that, on your star chart, this formula is given to you flat out. There's no like mixing and matching like we've done the last couple of days. On your star chart, it says the volume of a sphere is V equals 4/3 pi r cubed. So instead of squared, it's to the third power. And the reason behind that is because we're still talking about volume. So remember, that's like length times width times height, three-dimensional. But since there is no height to multiply by, that's why we cube the radius, okay? So just like before, if they give me diameter, I have to cut it in half and use the radius. So the difference is whenever it comes to the hemisphere. So a sphere, you use this formula. So what do I do if it's asking for a hemisphere, which is half of a sphere? Well, all you do is take your answer and just divide by 2. And we'll talk about that here in a second, okay? So let's first start with number 2. Probably started with the wrong one on number 1, but number 2. First things first, what part of the circle did it give me? Did it give me the radius or did it give me the diameter? How do I know? Well, this line here goes halfway across the circle. So 8 is the radius, which means I do not need to cut it in half, okay? So V equals 4/3, here's my new formula, times pi times the radius, but instead of squared, we're going to cube it, and there is no height. Again, for the new calculators, the fraction is alpha xton, and it's not xton, but there you go, 4/3 times pi times 8, but when I do caret top, make sure you type in a 3. So the volume for this one is 2,144, and I think we're going 1 decimal place, so it would be 0.7, and they would be units cubed, okay? So let's go back to number 1. What part of the circle did it give me? It gave me the radius. How do I know? Because it's already halfway across the circle, so I do not need to cut it in half. So the process is the same. We're going to do 4/3 times pi times 6 cubed. So do that part first. Oops. Times pi times 6, but don't forget when you do caret top or exponent, it's to the third, okay? But here's the kicker. Because it's a hemisphere, I have to divide my answer by 2, okay? Because I have to cut it in half. So my final answer is 452.4 units cubed, okay? Number 3, what part of the circle did it give me? It gave me the radius. How do I know? Because it's halfway across the circle. So then I'm going to do the same formula, 4/3 pi times 10 cubed. But since it's a hemisphere, I'm going to divide by 2. So you do that first. Oh my. Okay, but I'm going to take my answer and divide by 2 because it's a hemisphere. So my final answer is 2,094.4 units cubed. Following. Number 4, what part of the circle did it give me? Diameter. How do I know? Because it's all the way across the circle from edge to edge, or whatever. So I do have to cut it in half. So instead of 16, we're going to use 8. Same formula though, 4/3 pi times 8 cubed, but since it's a hemisphere, I do have to divide by 2. I always put a 1 there, don't know why. Times 8, but then take my answer and divide by 2 because it's a hemisphere. That is where science comes into math, because a hemisphere, you talk about north and south, west hemispheres, something like that. Units cubed. All right, number 5. What part of the circle did it give me? It gave me the diameter. How do I know? Because it goes all the way across the circle. So half of 24 is 12. When I type that in, this time, because it's the entire sphere, I do not need to divide by 2. So don't assume that you have to divide by 2 every single time. Oops. So my answer is my answer. I only divide my answer by 2 if it's a hemisphere. Following. Number 6. Same thing. What part of the circle did it give me? Gave me the radius, so I don't need to cut it in half. So, oh my goodness, I'm so used to putting a 1 there. 7. So I don't need to cut it in half, so my final answer is 1436.8 units cubed. Okay, now just to show you why the hemisphere is important is because this was on a STAR test a couple of years ago, and it takes what's called a composite figure. Y'all kind of talked about this, y'all did talk about this in 7th grade, but this is where it comes into 8th grade. Notice what two shapes are in the picture: a cylinder and a sphere. Okay, so let's focus on the cylinder first. Okay, so you kind of avoid this dome part right here. So what part of the circle did it give me? It gave me the radius. How do I know? It's halfway across. So then I don't need to half it. If you remember with the cylinder, the formula for the cylinder a couple days ago was V equals pi r squared times the height. So in this case, pi times the radius, which is 3 squared, times the height of the cylinder, which is 7. Then we take the hemisphere, V equals 4/3 pi, which is focusing on the dome part, okay, times 3 cubed, because remember, it's that formula. But I need to cut it in half because it's a hemisphere. It's not the entire sphere. So with that, let's do each piece. Pi times 3 squared times 7 is 197 point, we're rounding 2 numbers, so 92. And then the hemisphere, I have to divide by 2 because it's a hemisphere, so it's actually 56.55. And they want me to find the volume of the entire figure, which means I add those two numbers. So I add the 197.92 plus 56.55, and I get 254.47, which means my answer is C. So that's where you can really see a hemisphere on these kind of questions.